Hello and welcome to Flame Tests and Atomic Spectra. This video will take you through what you would have been doing in lab, but we're going to do this in a distance way. So bear with me. It's a little hard to see some colors, but I'll try and talk you through it. So remember what we did first is we looked at some known elements that we were doing a flame test with. So I actually put a little methanol in each one of these cups that you see here in the fume hood, and that provided some fuel in order to heat these elements up. We're seeing those elements being heated and exciting the electrons. When those electrons return to the ground state, they give off characteristic colors. And so the first thing we need to do in our lab manual is to write down the 6 elements that we're going to be looking at, and we'll get some color observations as we watch those being ignited. The first one I ignite here is sodium, then barium. This one we're going to ignore, go straight to copper, potassium, strontium, and lithium finally. So for that sodium, if you look at the flame here, you kind of have to look past the blue. That's the color of the methanol. The sodium itself is going to be like a bright orange color. The barium is looking rather green. We're ignoring that one in the middle. And then copper is green as well, but notice it has more of like a lime color to it. Potassium is a peachy violet color. That violet's going to come out. And my strontium and lithium here are a little short, so let me tell you that the strontium is red, and the lithium also has red, but almost more of a magenta hue. So once you have your colors written down for these flames, what would have happened if you were in the lab is you would go ahead and have samples of these elements that I dissolved in water. And we put a little wooden splint in that water, and we actually put that wooden splint in a Bunsen burner. And so here for the next part of the lab, you're going to see these unknown samples. So these are now in a different order than the elements that you just recorded above. But we have unknowns. Unknown 1 gave us this green color. Unknown 2, notice this red. Unknown 3, more of that limey bluish green color. 4, more of a magenta. 5 was a bright orange. And 6 was this lovely violet. So probably pretty obvious there what those unknown elements are, but you want to go ahead and write those in your manual. If ever we do come together, I would love for you to see these flames in person. They're really pretty. The next thing we would do in class is look at these electrical boxes that I have that we can light up these spectral tubes. And each one of these tubes are particular gases, right? And those gases, again, are going to be excited this time by electricity. And we're going to get to see that emission of light coming off of them, okay, as those electrons again return to the ground level. This one right here is hydrogen, this one is helium, this one is the bright lights of neon, and then over here on the right is our nitrogen. So those are the 4 that we're going to look at. Again, hydrogen, helium, neon, and nitrogen. And so what we're going to do in our lab manual is, if you were here with me in class, you would be given some colored pencils, and we would be doing some coloring of the things that we see. Above here, we would first look with our spectral glasses at some white light, and you would see a continuous spectrum. So white light is a mixture of all of the colors, and we would see this continuous rainbow of colors. So some options for you at home would be to actually color that with colored pencil in that box provided. Or maybe you can do a printout of a rainbow and paste it in. Or of course, the last case would be maybe a verbal description of those colors as they transition one to the other. All right, so Then what we would do is we would look at our spectral tubes and we would look at them through our spectral glasses, and that breaks the light that we see. So back here we saw the light all mixed. Look at this one, for instance, hydrogen, almost this pinky color, right? It breaks it down into the particular line spectra that we see that can be associated with those very specific energy levels that electrons can exist in these particular elements. So these are like our fingerprint patterns for these elements. Again, the best case scenario would be for you to color these with some colored pencils. You could find them online, I did, and print those out and paste them in. Or at the very least, you'll want to write in some words like purple, blue, teal maybe, and a reddish orange, okay? The point is you want these patterns, and what we're trying to do here is just respect the fact that each element has its own pattern. So it's not like you have to memorize these patterns. It's not like you have to dive into them very deeply, but you do want to recognize that they each have their own pattern. And if we know what those patterns are, when we're given an unknown, we can pick out what we have. Okay, so again, do your best to record these 4 elements spectral drawings. And then what I would have done is I would have very sneakily picked one of the tubes out to put back in without telling the students, and they would look at it. Here's the one I'm picking for us. They would look at the spectral tube and they would look through their spectral glasses at the pattern, and using their knowns, you would write in that spectral line pattern and what you believe to be this unknown element. So you can do that in your manual. Again, probably pretty obvious, but some things translate well virtually and other things we kind of have to just go with the flow. And finally here at the end of the lab, you're going to put all of your knowledge together in a couple of sentences that explains what's happening in terms of electron behavior when a bright line spectra is produced. So sound intelligent might take a couple of tries to kind of like make it sound like it needs to for understanding, but I will be looking for the words electrons, not necessarily in this order, lower energy levels, higher energy levels, excited state, absorb, emit, and light. And you should thoroughly explain what's happening when we have our bright line spectra produced, okay? So again, I hope that you get to see this in person someday, but in the meantime, get this lab written up and be excited for what's coming next in chemistry. Thanks for watching.